My name is Niyi Kushimo. I am the technical lead in Webfontaine, Nigeria. I Today I'll be taking us on this topic, gradient descent and Autograd, and you know that this is week 1, day 2 of our deep learning course, and we'll be having for the purpose of this video, we'll be having a nice time on Autograd, and that is in section 2 of this tutorial. So Autograd is actually a automatic differentiation engine in PyTorch. That's why it's called PyTorch Autograd. And I will need to explain that Autograd is actually a reverse differentiation system. It records executed operations to produce a directional acyclic graph. And one thing we need to know is that the leaf of this graph is actually the input tensors, and the root of the graph is the output tensors. So it does this using the chain rule, and from this explanation you will see that Autograd is actually can be conceptualized or understood as a graph of graph of functions. Yes, graph of functions. And we need to understand that one of the major use of this for Autograd is for optimization. And ML, that is machine learning and deep learning algorithms, can be very complex and cumbersome. So complex in the sense that they can be multiple level nesting. So what it means is that when a function has another function in it, and that function has another function, then we are talking about different level of nesting. So some of these machine learning algorithms can have multiple levels of nesting. What Autograd helps to do is that it helps to achieve commensurate optimization on on these algorithms, or for these algorithms. So we have other algorithms like gradient descent and the likes, but today we are focusing on Autograd. And if you look at my screen, we are looking at this function, which is a single neural network, very simple and straightforward. And what we are concerned about is to find the derivative of the cost function, which is usually defined with the inclusion of learnable parameters. If you look at from here, our learnable parameters is W and B, which is the width and the bias. So in this case, it is the width and the bias. And if you look at the code, it is actually defined, stated. This is the definition of the class. This is the definition of our our parameters. And here we are making them learnable. Actually, if you see in this function, we can actually comment these. We can actually comment these to. We don't need to raise any error. So in this case, in the prediction, we need to just put in our value, our code to. If you look at this, we're actually going to be predicting with the part before the minus, this part. So that's what determines the value of that's what determines the value of our function, our prediction rather. So what we'll be doing is time h, then we have our x multiplied by our parameters, then plus self dot b. So like I said earlier, these are parameters, and we are using self because this is in a class, and also to define the other aspects, which is the loss. We just need to do the difference of the actual value and the predicted value. So what we are getting is the true y minus y, which is predicted. So let's call this prediction, and we have the square of that.